All right, I'm back. We are doing special factoring, not just regular factoring. This is special factoring. These are two common patterns we see in various types of algebra, all the way on up to calculus and beyond, where we have the difference. That's the subtraction. Remember what our algebraic words mean. We are subtracting two perfect squares. So whatever that is, it's a perfect square, and whatever that is, that's also a perfect square. Something times itself. And then our second special factoring comes when we encounter a perfect trinomial square. So to understand what that really is, I want you to do a quick little bit of foiling. So multiply x plus 7 times x minus 7, okay? If we FOIL this out and we do our first term, we get x squared. And if we do our last term, we get 49. But if I do the rainbow bits, I am going to get plus 7x and then minus 7x. And guess what? When we combine those, poof, they're like matter and antimatter. They cancel out, and we get x squared. That is a minus 7 times a plus 7. I left that blank and I filled it in wrong. That is a minus 49. Always the difference of two squares. So in your worksheet, you're going to have a bunch of these to do, but you'll see the pattern very quickly. Now look up here and you'll see that those are fitting that pattern where x squared is x times x and 49 is 7 times 7. Whenever you see a subtraction sign and no middle term, and these guys are perfect squares, you can always factor them to be the square root of that number, x, and the square root of that number, 7. And then it's just always a plus and a minus, or a minus and a plus. It does not matter the order in which you do them. All right? So it's very, very common. All right? So on your own, take a look at the worksheet. See if you can factor x squared minus 16. Okay? How do you factor that? Pause me, come back. I'll write the answer. Here we go. It is x plus 4 times x minus 4. All right? Hope that shows up on screen. X plus 4 times x minus 4. This one, a perfect trinomial square, a little bit more difficult because we do have a middle bit, but you'll see that it's always in a regular pattern. So again, to practice, try x plus 3 times x plus 3. If we FOIL that out, that is the same thing multiplied by itself. So I could have written x plus 3 squared. All right. If I go to multiply this out, I get an x squared. And my rainbow bits now are always exactly the same thing, a 3x and a 3x, which gives me 6x. And then now when I multiply those, I get that square again, 9. So anytime you get the square root of this number being exactly half as big as this number, you're going to have a perfect trinomial square. And that's right now when the coefficient is an invisible 1 right there. Okay, so when does this happen? When we get x squared plus some number here like 20, and then if I take half of that number and square it, this will be a perfect trinomial square. If I want to factor this, all I need to do is write x and the square root of that, 10 and 10, and you'll see that whenever that sign is going to be a plus, this will work. If that's a minus, it will not work, but it's always 2 of whatever those signs are, plus and plus. If this had been a minus, these would have both been minus signs, all right? So again, half of this squared has got to be equal to that, all right? That's a perfect trinomial square.